Good morning again, everyone. Once again, my name is Taylor Davis, the Interim Race Technical Director. And one of the things that we're about to talk about is a very important marketable skill as an engineer. One of the most important things that I learned early on through Solar Car that I was then able to apply through my engineering degree was working with a computer-aided design program. And now Kyle and Ali are about to introduce us to their program, Solid Edge, and they've got a lot of really good, really useful ideas and innovations that have been implemented in that program, which I think you'll all find very useful for your own cars. So without further ado, Kyle.
All right. Thank you, sir. So again, thank y'all for being here, and again, thank to Dr. Marks for allowing us to come talk to you about Solid Edge. So one of the things I want to ask, let's see if we can get this thing to, there we go. So Ollie and I are going to be presenting for you. I'll do a little bit of intro, and then Ollie's going to go a little bit deeper into how the software works and how it can actually help you in there. Let's just get right into it. So I want to ask a couple of questions because we want to get a feel for what you're doing today with CAD. So how many of you are actually using computer-aided design? Okay. Better question, who's not? Okay, cool. A couple of them. All right. So one of the things that you can get from us today, we have postcards here because what Siemens does for the educational community, for high schools, for students, even colleges, we give our software away for free. Okay? There's no strings attached, right? You can go to our website, you can download it, you can have it for free. And it is a full-blown, our premium package was around an $8,000 package. Okay? And what we do is we poison the file so you can't use it inside of a commercial license, right? But you have the full breadth of the license that are inside of Solid Edge. So, how many of you have actually been using CAD for, let's say, less than a year? Who's been using it for less than a year? More than a year? All right, good. So we've got some experts in the room. So what are some of the names of the CAD programs that you're using? Just shout them out. SolidWorks. AutoCAD. What was one over here? Inventor. Okay, AutoCAD. All right. Fusion 360. Awesome. Okay. Now, one of the questions that I got asked earlier is, what kind of hardware the Solid Edge run on? And really, any computer with an i5 Intel processor, 8 gigabytes of RAM is a minimum, right? I was telling the gentleman up here earlier, you can run it on a Surface. Right, so a Microsoft Surface, it runs beautifully on a Surface if you do that. It is a PC only based software. Okay, it's not Mac, but it is PC based. So really, 8 gigabytes of RAM, an i5 processor, those are really the minimums. Okay, it's best if you had an NVIDIA gaming card would be best, but it still works with an Intel built-in processor. You just probably won't get faster rotations and stuff like that. What kind of parts do you guys design? Do you design the whole entire car? Do you use the motors that are inside of it? Yes? Pardon me? The whole car? Awesome. Do you do the wiring and the electrical and everything like that? No? Yes? Some do? Okay. Well, what we're going to be able to show you is we're going to be able to do all of that, right? And I'm sure some of you, we were talking about earlier the materials that go in the car. You got the motors, you got the wiring, you got the electrical. Do you ever have to figure out what the weight of the car is? Yes? Well, a CAD program will do that for you. Okay? You can get some simulation going in there to see how much forces are going to go down. When you have your suspension in there, you see how if something's going to break based on a certain force. Okay? Now, one of the things I wanted to show you is an example of a company who, back in 2012, they're going to tell their story, but to kind of lay this up for you, the Edison Electric Car. Anybody have heard of the Edison 2 electric car? If you're like me, you probably didn't, but okay, some of them do, right? So back in 2012, there was this competition called the XPrize. And it was a $5 million prize for the person or the group who could come up with a very lightweight car that can hold 4 people and could get 100 miles per gallon. Okay? 100 miles per gallon. Okay? Now, what they did is they came up with an electric car, right? And what's interesting about this is a lot of patents came out of this car. And if you'll notice here, there is no suspension. There is no A-arms. It's a solid axle. That's because a patent that they actually designed inside of Solid Edge is this right here. That is right there. That's the gear drive. That's the suspension. Everything happens inside of the wheel. Okay? And they've actually selling it to companies now. You can see here. Here's the electric motor. Here's the axle that's driving the gear. There's their brake. And it was very revolutionary. And this is part of the reason why they won won the prize. You can see this is the first version. So now they have a second version of the car. It looks a little bit more commercialized, right? Something that I would want to go out and buy. But that's what Edison is doing, and they're doing this inside of Solid Edge. So here's the CAD model. You can see the transparency of that, so you can see the frame and everything that's inside of there. And these are just the possibilities. You can design the surface on the outside of the car and everything like that. But let me have Edison tell you the story of how they use Solid Edge to build this car.
The XPrize Foundation announced the Progressive Insurance Automotive XPrize in 2008. That piqued Edison 2's founder, Oliver Kuttner's interest, and he decided to go after the prize, go after that $10 million prize purse that the XPrize Foundation was putting up to design a clean, safe, affordable vehicle that can get over 100 miles per gallon. He ended up putting together what amounts to a dream team from endurance racing. We have over 20 wins at Le Mans, Sebring, and Daytona. From there, we looked at really what it meant to build an efficient vehicle. Not just moving from one power source or one energy source to another, but at the heart of it, how do you build a vehicle that takes less energy to move. And what ended up coming out of that was the very light car. Everything was designed in Solid Edge. It gave us the tool we needed to accelerate the design in a very short time period, and within 2 years we were able to do the analysis that I was just speaking of, do the design work in Solid Edge, build 4 prototypes, compete in the XPrize on track, and then going into the labs and winning the mainstream prize, which is the $5 million prize. The 3 areas that we focused on were the brake rotor assembly. We also focused on the pedal assembly and the frame geometry. As we're moving forward with the next generation car, it's going to have a larger wheel size, and it's also going to be a little bit heavier. So with those 2 going hand in hand, it gives us the opportunity to increase the size of the rotors to help with the braking capability of the vehicle. And in doing so, Synchronous Technology is a great way to make a modification like that. Using the old history-based method, it could take days, depending on how difficult the assembly was being, if it were going to blow up. But with Synchronous Technology, you can literally do the change in minutes. It just saves so much time. The same with modifying the pedals. It was more for ergonomics, for the driver comfort. We had to bring the pedals down a little bit closer to the floor, and once again, that's not quite as complex of an assembly as the brake rotors were, but Synchronous Technology just made it absolutely easy to perform with parts that weren't designed in Synchronous. They weren't designed to be modified. in the way that synchronous technology allows us to modify the parts. The third area we focused on was the frame. As we move forward, we're having to modify the frame slightly. As we go through some crash simulation, we try to increase the energy absorption of the crash box with the frame. In solid edge, synchronous technology allows us to make the changes to the geometry just effortlessly. With the inner part linking, being able to move one piece and having it modify all the rest of the tubes. You know, it's not just with tube design, it's also with parts and assemblies. You can move one part and it'll redesign the bracket and change the bracket so it fits. At the heart of the XPrize Foundation, they try to look at industries that are viewed as being stuck in their path forward. And they felt that, you know, the automotive industry sort of fit into that category. There hadn't been any drastic leaps in fuel efficiency for a while, and they were hoping that this prize could help spark a future generation of engineers to design cars that can get over 100 miles per gallon. You will see bits and parts of our technology on the road in the years to come. You're going to see cars that look like ours. You're going to see cars that are a lot lighter, have a new architecture like our vehicle, and hopefully we can be in that new generation of automotive players. We can get our car out there to compete with all the rest of the manufacturers. We are moving forward. We're developing our car. The next generation very light car is going to be designed just like the previous one, all in solid edge. The only difference is that after learning about synchronous technology and getting to play with it a little bit, we plan on using synchronous technology a lot in developing the next generation car, and I think it's really going to cut down on the time to production with our pre-production prototype.
So he probably said a term that you're probably not familiar with, and that's called synchronous technology. And what we did back in 2008 is we introduced this way of designing. Those of you who've been using SolidWorks or Inventor or Fusion, you use what's called a history-based system. Other things happen in order in that everything that you design with a sketch first and then you extrude it, right? And there's parents and there's child and stuff like this. Well, with synchronous technology, we took out the middleman. Because we asked the question, it's like, well, why should a 2D geometry be driving 3D geometry? Why not just drive the 3D geometry? Why not just modify it directly? And that's what we do. But we do it in a unique way in that you have design intent whenever you draw that sketch. Something is concentric, something is tangent, something is symmetric. Well, that's what we're doing with synchronous technology in the 3D model. Whenever you grab a 3D model, we interrogate that model to see if something is symmetric, if it's tangent or it's concentric. And as you move it, it interrogates that model and it changes the model. And what I'm going to do is I'm going to ask my colleague Ali to come up here and to talk about that and to show you some videos that will make you think about it. One of the things I didn't know if you noticed it or picked up on it, but that pedal assembly had 3 separate pedals. Each pedal was a unique part, but they edited all 3 parts at the same time at the top level assembly. And that's one of the benefits around synchronous technology. We didn't have to go into every single part, make that edit, and see if it was exactly the same. So that's the uniqueness that Solid Edge brings to the table for you, and to be able to design your car a whole lot faster, right? So you can figure out your problems quicker down the road and be able to test your car for a lot longer period of time rather than having to design it. So, Ali, why don't you come on up here and tell these great folks about how Solid Edge can help them.
Thank you. So as Kyle said, we have a technology here, synchronous technology, unique to Solid Edge. There are no other CAD softwares out there that can do this. What I like to call it is history-free modeling as opposed to history-based. And the CAD software that some of you guys mentioned, Fusion 360, SolidWorks, is all history-based, which means you start with a base feature, you start a sketch, you make a feature, and then you build on top of it, build on top of it, build on top of it. Now, what's going to happen if that first feature changes? Then you go change that feature, but then everything else has to regenerate. And in many cases, what happens is that all the other features won't regenerate. because they're all dependent on the first base feature. And that's a big problem because it makes editing take too long. So you have to go modify every feature, make it work again. And in assembly, it's the same thing. One thing changes, a lot of other things change. And then in history base, what you have to do is go into each part, as Kyle was mentioning it, and edit it one by one, make it happen. In Synchronous, you don't have to do that. You can modify everything at the same time in assembly level. Here I have a video for you guys. It's a part that I made. It's basically a car body for an F1 Formula car that I made in Solid Edge. As you guys can see, it's very similar to the other programs I use in terms of it has all the commands, it has all the drawing commands that you can use. But as you can see on the left side on the Pathfinder, there is something called Synchronous. What that allows you to do is basically sketch into environment. You don't have to go to 2D anymore. As you guys see, I'm 3D and doing all that. And making an extrude, as you guys saw, it's as easy as dragging and something like that. It's very, very simple, and it's very fast. You have all the traditional commands right there in terms of extrude, revolve, round, thin-wall, or shell. You have all those commands available. You have everything that you need. And to top that off, if you guys ever use Synchronous Technology and you see there is a learning curve and you want to move back to ordered, we also have history base available in the program, which is very huge. Due to the Synchronous Technology, we also have ordered history base available. As you guys will see at the end, I use them at the same time. So what I like to do is to use Synchronous for the parts that I don't make edit, that I'm going to make edits to in the future, that I'm going to predict I'm going to make edits. But sometimes I use ordered for the parts that I see there won't be any edits needed in the future, as I will do here in a second. So that's very huge. We have both modes available for you, history-based and Synchronous. So you can go from one to another. But once you start using Synchronous, honestly, you basically don't want to go back to history-based. That was my experience with Solid Edge. As you can see, I switched to ordered for history-based modeling, and I'm going to add some couple of rounds here. So yeah, because I'm going to predict that my rounds won't change in the future, and I don't have to worry about all that history tree anymore.
Ali, what CAD system did you learn on?
I started with Creo, PTC Creo.
Right.
And then I moved to SolidWorks. But then when I started with Solid Edge, I can't go back anymore. So
how was that experience, though? You said you learned 2 other CAD systems, but, you know, how was it trying to learn Solid Edge from your others?
It was actually very simple. And what advantage that Solid Edge has the Synchronous Technology, when I started learning CAD in Creo, I would sit in exams in university, and I would design a part, and I would make a mistake, and then go back to all that history tree and modify it. And then now I think about it, I'm like, if I had Synchronous back then, I wouldn't have to worry about a thing. I can just edit at the right time and very efficiently. Now, the editing is not the only feature allows you to do. One of the main things...
Step a little bit closer.
Yeah.
There you go.
One of the main things that Synchronous allows you to do is to grab parts from GrabCAD, from other CAD softwares, bring it in Solid Edge and modify it. Because in Synchronous, we don't care about the history tree anymore. And once we don't care about the history tree in a sketch, it really doesn't matter what CAD program you made your part in. You can bring it in our program and modify it. So if you see a part in the GrabCAD that you guys can see it's made in SolidWorks or Fusion 360 or all other CAD softwares, and you see that you want that for your car, but you don't have SolidWorks available to go modify it, it's very simple with Solid Edge. All you have to do is basically bring the part into Solid Edge, and as I'm going to show in the next video, it's very simple. You just put a smart dimensions on and change the dimensions. We can even recognize the patterns for you. So if you see a gear on GrabCAD that you want to use, but it was made in your program, we can even do that for you and recognize the patterns. Here I have an imported part for you guys. I believe this part was made in SolidWorks, and it's very simple. The first thing I'm going to do, I'm just going to change the color. I didn't like the color of the part, so I'm going to go ahead and change the color to red. The next thing I'm going to do is that I'm going to change the dimension of that feature. It's very simple. I use the feature we have in Solid Edge available called Smart Dimension. I just put a dimension on it, first thing, and then as soon as I click on the dimension, it allows me to change it. So I can go ahead and change whatever dimension that I want in the part, and it's as simple as that. I can even make it go symmetric, as you guys can see. So another big thing is that I was mentioning in terms of gear is the pattern recognition that I have available here. You guys can see the pattern recognition. I think those teeth are a pattern. So what I'm going to do is that I'm going to use the pattern recognition feature that I have available in the software. And then, as you guys can see, it recognizes the circular pattern. And once that happens, it makes the pattern for me on the left side of my Pathfinder. And then I can just click on the pattern and change the number of it. Make it as many as I want. In terms of 10, make it 12. So as you guys can see, it's very simple. Not only the circular pattern, I can actually recognize rectangular patterns too. And this is very important to know that this part was not made in Solid Edge. And it was made in SolidWorks. So try it with any other CAD software. Bring a part in, see if you can bring a part in from another CAD software in your program, see if you can make edits as fast, efficiently as Synchronous Technology can in Solid Edge.
Yeah, one of the things that when we were developing this is you saw how he could change the direction of the dimension. I don't know if you've ever done this in a 2D sketch, but you went to go change the dimension, it went the other way, and you're like, dang it, I want to go the other way. Well, you can do that with Solid Edge very easily. So,
and that's in terms of basically imported parts from other CAD softwares. Now, in the next video that I have, I'm going to show you guys how you can make your mechanical drawings with our program. You don't have to sketch it on the piece of paper anymore, dimension and all that stuff. It's very old. In our program, you can basically bring in any part that you made and basically make engineering drawings that you guys can see. It's going to automatically recognize the views that I want. I'm going to bring in three different views from different sides of this simple part that I made. And what I'm going to do is that I'm going to use the smart dimension and dimension it. So as long as you made that part in Solid Edge, or it doesn't really matter if you made it in other CAD software, as long as you have the 3D part for it available, you can use the smart dimension and dimension the parts. So when you want to submit your files for solar cars, you can basically use this to dimension all your different dimensions that they ask you and require you to do. This is a very simple part, but you can do the same thing with assemblies, basically. In a second, I'm going to show you another basically feature that we have available in terms of drawings. I like to call it Quick Sheet. It's to streamline your engineering drawings. So if I make one drawings, and I think that I'm going to make hundreds of those with the same views from different parts, I can use Quick Sheet to streamline that. So basically, Solid Edge saves the types of views that I have. So if I bring another part in, it's going to put it in the same type of views that I did. I don't have to make all these different edits that you guys just saw. And it's very simple to make a Quick Sheet. You just go to the commands. In terms here, I'm just saving it, basically. It's very safe. But then on the left side, you go to the application button and you find the Quick Sheet command available in the tools. Or in the settings, it's create Quick Sheet right there, and it creates the template very easily for you. So if you have 100 parts for your solar cars that you want to make engineering drawings of, send it to your machine shop to machine it for you. Basically, you can just use the Quick Sheet and streamline that whole process.
So think about, but Dr. Marks, correct me if I'm wrong, but you have certain standards of what the drawing needs to look like, right? So, you're probably familiar with templates, drawing templates and stuff like this. This goes beyond a drawing template because with the Quick Sheet, you're defining what those views are, and you simply drag and drop that part in there. All the dimensions, all the section views, everything comes up and it's already done, right? So you can build a quick sheet based off of the template or what the standard is for the solar car, and have that already at the ready and create your drawings very, very quickly.
To add to what he said, I wish I had that during my exams at the university, right? I make 6 different parts, and the professor asked me to make drawings for all 6 different parts. If I had that quick sheet available, it would be so easy. It would just take as much time as making just one engineering drawing.
And a quick sheet, we have tabs down here just like you would in Excel. If you have a quick sheet and it has multiple tabs, it does all the tabs. It does all of them. Even if it's an assembly view or whatever, just simply drag and drop it in and you're done. Okay?
And finally, in the last video, I'm going to show you guys the electrical features that we have available in Solid Edge. A lot of, I think you guys have to actually submit some schematics and electrical wiring for your solar car. And in Solid Edge, we have all that available here. We have the schematics available that you can make different electrical schematics very easy. We have different commands available for it, all the different things you use for your electrical schematics. And we also have wiring available. And that wiring is very important, I think, for most of you guys, because you can actually simulate the length of the wire, basically do the wiring your whole car inside CAD to figure out how long that wire is, or bundle the wires together. Mm-hmm. And that's very simple here. It's to still make add in some schematics, but in a second we're going to get into some electrical wiring and how you can create the wires in your part, because your cars use batteries and all that stuff, and the wiring is a very important part. As you can see here, we go inside the model and we're going to start making some path for our wires, see where our wire is going to go from here and there. And you guys can see it's all those wires already created, and it's very simple. It's just creating basically a 3D path for your wire from where you want your wire to go from to where you want it to be at, and basically create the wire. And we have many different types of wires available for you with different colors, so you can experiment the type of wire that you want, what color you want, all that stuff. You can experiment with it in our program. So here, I think we can skip this part of creating the wire, and we can actually go show you guys a finished product of the whole thing, because you can see all those are different types of wires that are already there, and you guys can see that those wires were just created right there, different types of wires, and it's as simple as just clicking the create button, and it's going to create the wires for you. And you can also bundle the wires together, make them go all together, and it's very simple as that.
Right. So one of the things that he's talking about here is you can see these connectors. Each one of these connectors has their own pin, right? You're all familiar with that. Well, you define what those pins are in the 3D model, and then you just tell Solid Edge, I want this wire to go from this pin to this pin in this connector, and you tell it which ones it does it, and then it automatically just routes it for there, right? And then you can put them in each one of these and put a sheathing around it. Go ahead, Ollie.
As you said, you can do all that, or you can also bundle them together, make them all come together. And in the next slide, I have a finished product of basically what wiring can look like in Solid Edge. As you guys can see right there, I made the wires go through the little openings right there. So these edits are very, very simple. It's as easy as just clicking on when your wires want to go, and the program will make the change for you. So it's as simple as that.
Right. Is that it? Next one?
Yeah, next one.
I don't know if I have. There we go.
And here I have basically a electrical product here. As you can see, we went ahead and made the PCB and all that stuff. And on the left side, you can see different types of wires. And you guys can see that they're bundled together as well. And all those different wires can be created with our program. And I think it's very important for you guys to use the program and make the wiring, because you can actually measure the length and all that stuff with our program.
So one of the other things that comes with Solid Edge, you may have heard of this program called KeyShot. Has anyone ever heard of KeyShot? Okay, not? Okay, great, I'll tell you what it is. It's a photorealistic rendering tool, right? And one of the things is you can build your car, and if you have sponsors and you have their logo, you can actually attach that logo onto the surface of the car. So you can get a full rendered product of your car that you can put on your website before you even make your car, right? That you could take to sponsors, or you can take to people and say, look, here's your logo. Where would you like it on the car, right? We can make it big, we can make it small, whatever, right? These are the types of things that you can do with Solid Edge that comes with it. So one of the things that we have is you can download Solid Edge for free. The link is on the Solar Car Challenge website, okay? It's there. It's a form. We also have some postcards to hand out to you that has it as well. We have some giveaways, so if you come up and ask us a question, we'll give you a little, widget, whatever, to give to you. But there's also a website dedicated to Solid Edge. Ali, can you talk a little bit about that?
We do have the GearUpU website available, so if some of you guys don't have any experience in CAD, you can actually go to that website. It starts from the very basics of CAD on how to make 2D parts and how to transition to 3D. So you can actually use those classes to learn CAD as well as learn Solid Edge. And also for some of you guys that are experienced, it goes into the very detailed simulations and assemblies that tricks and tips available in Solid Edge. So it's both for both groups, the ones that don't have that much experience in CAD and the ones that are also experienced. There are different classes. We have 4 classes available that take you guys from 2D drawings all the way to assemblies and simulations. So I recommend that all of you guys try that website. It's fully free. All the classes are free. Just go to that website and all the videos are there. Just follow along with the videos and you'll be expert in Solid Edge in no time.
Right. And yes? What version of Solid Edge? Well, currently the latest version is 2019, and whenever you go to download that Solid Edge version for students, it will be 2019 is the version.
Another question, can you export to like a CNC machine or a 3D printer? Or
Yes.
If you go to have your schematic, if you need to make a board?
Yeah, a wire board? Yes, you can. Yes, sir. Right, and we have, directly inside of there, you can go file 3D print, and you'll be able to see, you'll be able to input, what printer you have, so what's the print volume, and so you'll be able to see how your part's going to fit in there, in that print volume, okay, it is there as well, and you can send it out to a CNC machine. Okay, great questions. Yes?
I just wanted to ask if your training videos in GearUpU are the same ones that you had in Udemy last year. Because there was a Solid Edge training course there in Udemy. Is it the same one or is it different?
Some videos are the same, but GearUpU class is basically some different videos as the Udemy class. So yeah, I recommend you try out both.
Okay, is this geared more towards actually making a solar car or car parts?
No, this one, GearUpU is basically, it's a very general class on terms of learning CAD, right? But also have a robotics class available. And if you guys are interested in robotics or more learning the mechanisms that go into these different types of stuff, you can also try that out.
Right. And we're continuing to work with Dr. Marks on, how we can actually expand this, for the solar car challenge in itself. Yes, another question.
Let me add something
yeah.
because it's an appropriate time.
Yes.
One of the things I'm very excited about is that we have been able to make some arrangements to have some hands-on learning experiences with this Solid Edge for you. And we're going to set up some times so it's not just a tutorial. There could be a location where you could go and actually
Hands-on.
practice this kind of thing, both for teachers and students.
Yes.
I think that's going to be key to you. And while I'm at it,
Yeah.
you know that the rules require that your documentation must be in a computer-aided form. I don't want to say deformed. I've seen some that are quite deformed. But you've got to do something involved in stepping up what you're doing. No more pencil diagrams. To help encourage this, we will be presenting a $1,000 prize this year for the best solid edge use of their system in developing their mechanical and electrical diagrams as a special incentive.
Yes. Thank you, Dr. Marks. Appreciate that. Yes.
And what are the requirements for the program, like Windows, Mac, or Chromebooks?
Windows.
It's Windows based, and basically i5 processor and 8 gigs of RAM, and you should be good to go.
Okay, thank you.
Any other questions? Was this informative to you all? Do you think that you could go download a free 3D solid edge CAD system? Yes? No? Yes? All right. Well, we encourage you all to go do that. Like I said, we have some postcards that give you the website, or you just go to the Solar Car Challenge website. It's out there. We're on the sponsored link in there. And we just thank you for your time.